Hello, Doctor. We are from Group 310, and I'm Jiaming.
I'm Lucian.
And I'm Marcus.
So I'm going to explain about the state diagram based on the design C given. So the diagram for the traffic light system is actually a move finite state machine. So basically, the output of the traffic light signals depends only for the current state, and the state transitions are controlled by internal timers with the system operating synchronously. For this state diagram, basically it consists of 6 states, which is S0 to S5, each representing different configurations of green, yellow, and red lights for the 4 directions, which are east, west, north, and south. The state transitions are driven by also the 2 timers. One is a long timer, we make it as TL. Another one is a short timer for TS. There's also the transitions are managed by an input called the terminal counter TC, which tracks the time for each state and triggers the change once the timer finishes. Basically, in each state, there's a specific combination of lights is active, allowing traffic to flow in certain directions while others stop. After the timer for the current state expires, which is the terminal counter I mentioned previously, the system transitions to the next state, ensuring a smooth and predictable flow of traffic. However, in state 0, it remains at its state because of the input TC terminal counter do not present. So it will keep looping until the long timer control it before going to the next state. The state sequence follows a cyclic pattern where after completing the final state S5, the system loops back to the S0 and continues the cycle. So this design ensures that all directions are managed safely and efficiently with green light time for each direction and smooth transitions controlled by the yellow lights. The state diagram guarantees that no competing signals are given, preventing accidents and ensuring orderly movement through the intersection.
And now I'm going to present about the schematic diagram. From the equation formed, we can implement it in quarters to form the schematic diagram. We use D flip-flop, NOT gate, AND gate, and OR gate to create the schematic diagram. Since there are 6 states, so 6 D flip-flop are used. Based on the zebra crossing system control module and state diagram provided, we can determine that there are 3 input and 14 outputs. We have added extra outputs S0 to S5 as shown in the schematic above so that we can determine the changes between the states. The blocks placed on the left-hand side of D flip-flop are connected to the input are derived from the one-hot equation. Also, we use OR gate to connect to the output blocks because OR gate allows the output to turn on if any one of the corresponding states is active.
Okay, now it's my turn. And we have created one simulation waveform for this schematic diagram. And for this, I will explain it by step by step. So at the initial, which is the default state, which is the S0, will be in high. Unless it meets the TC input, which is the TC from the timer module. If the TC is set to be high, and then for the next clock cycle, when the clock rise at around 30 nanosecond, then the S0 will be set to low, and then the S1 will be set to high. This is like the transition from state S0 to state S1. So like consequently, when the TC is also high at the next clock cycle, the S1 will be low and then you transit to S2. And then for S3, S4, S5 is just the same. And then for S5, when S5 receive a TC signal when clock rises, then it will go back to the S0 state and then continue the loop. So like for S0, the output is based on the state diagram, which is EGE, East green, NR north red, and west green, and also one more is S red, south red. So it's the output is based on the state diagram.
Now I will explain how we get this table from these two pictures for every state. During state 0, when state 0 did not receive signal from timer module, if we go back to state 0, which east and west will be green, north and south will be red. North and south will be red, and the timer is TL, long timer. When during state 0, if we receive a signal from timer module TC, if we go to next state, which is state 1, so east and west will be yellow, north and south will be red, and the timer is short, timer TS. During step 1, when it did not receive a signal from timer module, if you back to itself, step 1, which east and west will be yellow, south and north will be red, short timer. So if step 1 receives signal, if we go to step 2, which only north will be green, other 3 sides will be red, short timer. When at step 2 did not receive any signal, so only north will be green, other 3 sides will be red, short timer. Step 2 receive a signal from TC. If we go to step 3, only north will be yellow, other 3 sides will be red, short timer, TS will be on. During step 3, when step 3 did not receive any signal, and we'll go back to step 3 itself. So only north will be yellow, other 3 sides will be red, short timer. And step 3 receive a signal from timer module. If you go to step 4, which north, east and west will be red, north, south will be green. And the timer is TS, short timer. When step 4 did not receive signal from timer module, did not receive TC signal, it will remain at step 4, which east, west, and north will be red color, red signal, and south will be green light, and this is TS, short timer. When S4 receives a signal from timer module, it will go to S5, step 5, which east, west, and north will be red light, and south will be yellow light, short timer. When step 5 did not receive any TC signal, it will south only green, yellow light, east, west, and north will be red light, short timer. So if step 5 receives signal from timer module TC, if we go to step 0, which east and west will be green, north and south will be red line, so the long timer will be activated. So when we combine all the steps, this is the table we get. And so we can conclude this with the equation, like e.g. when east green when state 0 did not receive signal TC and S5 receive signal TC. We also can notice that east and west having the same output, so they can share the signal. We also notice that east and west having the same output, so they can share the signal. So we can do, when the equation is too long, we can do simplification to simplify the equation.